it's Jacob Barnett here with a recitation following up the lecture I had on scientific notation. To my younger audience, I would just like to say what's poppin', man. So, grab yourself a snack and work out the 6 problems I got on my board. I got some chips, Ethan's got it.
I'm ready. I got snack packs and with the low-fat milk. Good for anyone.
So, here, why don't we zoom the camera in on these 6 problems. You could pause the video now and work them out, come back later, resume the tape, and see how I did it. So, see you soon. Welcome back to recitation. So, these problems were selected not just because they're random numbers, but because they have some actual application in the real world. For example, number 1, 137 is how much stronger the strong force is than electricity and magnetism. So, what happens is there's a proton here and there's a proton here, and so they want to repel. But thanks to the strong force, it's 137 times stronger. So the protons can stay together in the nucleus of an atom. Therefore, we can have all our atoms and all our chemicals, and, well, that's that. So, for 137, what we're going to want to do is, we're going to want to count the number of decimal places after it that is not the first digit. So, oftentimes we'll mark the first digit, and then count these. So there's 2 digits after there, 3 and 7. So it's going to become 1.37. The other digits you could follow up by a decimal place, times, and there's 2 digits, so 10 to the 2. I usually write my answers out in this box, so I preliminarily made this huge purple box. For the next problem, 32 feet per second squared is going to be how fast you accelerate due to gravity. So, here, that's your acceleration due to gravity.
Like if I jump out of a plane?
Yeah, if Wesley does one of his toboggan slides down the roof.
I don't do toboggan slides down the roof. I do backflips on dirt bikes if I had one.
Yeah, well, you'd probably do it off the roof if there was
I would.
Okay, so for this one, what we got to do is, for number 2, again, put a line here, count the digit, and so you get 3.2 times 10, and there's 1 digit, so there's a 1. Some people won't include the 1, but I'll just include the 1 for this reference. For number 1. So check marks next to these to show that we've gotten these done. For number 3, this distance is the distance between us and the center of the Milky Way galaxy. So, this distance is 25,000.
For those of us concerned with 2012.
For those of us who are concerned with the whole 2012 conspiracy that the black hole in the center of the galaxy will suck us all in, so mark your calendars for December 21st.
Any words of comfort to us that are living in fear?
Well, that ain't gonna happen. This is just a joke. Obviously, how would that thing get enough gravity in order to create the gravitational effect in order to suck us in? So, obviously, this ain't correct. But, some of you are conspiracy people, and, well, you can believe what you want to believe. So for this guy, we have 4 places after, so we count this, and we count all the digits after, and we have 4 more. So let me erase this. So here's a 2. 5 is one of the digits, so the other 3 have to be 0. solve that one. Let's move on. For number 4, this is the speed of light, which, for those of you concerned in relativity, you know that it travels at the same speed no matter how fast you're going. So, speed of light, going with speed times 10 to the 8 meters per second. And so, for this problem, what we're going to do is, well, there's no digits after the 3, so all the digits are going to be 0. I'll give a more precise value of the speed of light at the end of the lecture. So this is 3, and now we need 8 zeros. I'm out of space. This always happens. So that's the speed of light in meters per second. Now, for those of you who want to be millionaires, raise your hand. So, for this problem, what we're going to do is, Ethan, you don't have to reach for the sky. So, for this, we're going to try to represent it in scientific notation. As you can see, you can count the digits after the million. 1, 2, 3, 4, 5, 6. There are 6 zeros after the million, so in turn, you get 1 times 10 to the $6.
Oh, scary 6.
So, many people will often omit the 1, but again, I'll show it just for the purpose of this lecture. Check mark. For those of you who didn't raise your hand, how many of you are holding out for $1 billion? If you were, then you'll find this example fun. And, well, so this one, again, we don't have anything after the 1, so we just have 9 zeros.
Go ahead. It's recitation, Ethan. You can steal the Doritos.
What are my Doritos? So, we have 9 zeros. 3, 4, 5, 6, 7, 9, 7, 8, 9. And there we have it. We have solved all the problems. Voila. And as I promised earlier in the lecture, a more precise value of the speed of light is given by this is actually how they define the meter, so probably about as precise as it can get. Thank you for watching, and thank you for coming to Recitation. See you.
Bye.